Good morning. This week and next week, we're going to be doing probability. Okay. You probably haven't done this yet. This is just a seventh grade TEK. So should be something that is brand new. Okay. If I were you on these set of notes, I would go ahead and just copy the first example and then wait. Okay. Answer it and then do the second one. Then we'll do the third one. So pause after we do every example. That way you can see how much space you're actually taking up. Okay. So go ahead and press pause if you need to copy the first part here, and then press play when you're ready. All right. So before we get into the real nitty gritty of probability, you have to understand what a sample space is. Okay, so a sample space is the collection of all the possible outcomes. And we can write this in a table, in a tree diagram is the most popular one, or just to list it. Okay, so it's just what could happen. You have to list all the possibilities of what could actually happen on any special event you're doing. So for the first example, we're just doing sample space right now. It's just pretty much just listing all of the possible outcomes. So the first example says, the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? So I'm just listing what could happen. Okay. So let's see. Well, it's a football game, so only one of two things can actually happen in a game, right? Somebody wins and somebody loses. So I can list here that the Patriots win and the Cowboys lose. Okay. What else can happen? Cowboys win and the Patriots lose. Okay. So it's just writing what could happen. Now I'm looking at that. I spelled lose wrong, didn't I? All right. Those double O's always get me. I don't know if they get you, but they get me. Lose. And I knew it looked wrong. My mind was saying that doesn't look right. There we go. Patriots win, Cowboys lose. Cowboys win, Patriots lose. Okay. So that is what could happen. I should have just put lost. I know how to spell lost. But we're just listing what could happen. So that's the possibilities. All right. So go ahead and press pause and write down number 2. All right. So second example. A number cube, okay, number cube is rolled. What are the outcomes? So a number cube is your basic die, okay? It's your 6-sided cube that you rolled when you play any kind of games out there. So I just want to know, what are all the outcomes on that cube? What could you land on? Okay, well, think about the numbers that are on there. I could land on a 1, a 2, 3, 4, 5, or 6. You're just listing what could happen, okay? I could land on a 1, 2, 3, 4, 5, or 6. I'm just listing it. Now, where it gets tricky, you're going to see a little bit down the road, is when you're doing more than one thing, when more than one thing is actually happening. That's when it gets fun. That's when you get really big tree diagrams, okay? But the number cube is rolled. You can land on any number from 1 to 6. Go ahead and press pause for the next example and then press play. Okay, example number 3. A coin is tossed. Any coin, nickel, dime, penny, quarter, it's tossed. What are the outcomes? So what could you land on if you toss a coin? I can land on tails or heads. That's what could happen. Okay, so I'm just listing all the possibilities, all the possible outcomes here. So heads or tails. Okay, go ahead and press pause for the next one. This one's going to be fun. Okay, so you should have written it down already. You toss a coin and roll a cube. So I'm combining 2 and 3. Okay, now the first thing you're doing is going to be what we call our branches. Okay, it's our tree trunks, actually. It's our tree trunks. So tossing a coin, I call that my tree trunks. Okay, so go back to the coin. What could happen if you tossed a coin? Tails or heads. So I'm going to write those down. Those are my trunks. So I have tails and heads. And I give myself plenty of room because I know it's going to branch out. Trees have branches, right? So that's the two possibilities. I have two trees because I have two outcomes. I can get tails or I can get heads. Okay? So we have our tree trunks down. Now we need to go into the branches of the tree. That's the second thing we do. We are rolling a number cube. And if you remember the possibilities on the cube, we had 1, 2, 3, 4, 5, 6. So each one of these is going to be a branch on each tree. Okay, I'll say it again. Each one of the outcomes of the number cube is going to be a branch on each tree. So let's go ahead and add the branches to the tails. We have 1, 2, 3, 4, 5, 6. So I can get a 1, 2, 3, 4, 5, 6. There's the branches. Now we do the exact same thing to my other tree, okay? I can get a 1, 2, 3, 4, 5, and 6. Okay? And we're done. I have both of the things in the tree. I have the tossing of the coin, that's my heads and tails. And then I have the number cube, that's the 1 through 6. Those are my branches, okay? So this is how it would look if it was a tree diagram. Let me show you how they would write this out, okay? So I'm going to put a little, let me get my highlighter so you can separate the two. How would they write this in a list or a table? They would use a T for tails, H for heads, okay? They're not going to write them out. So they can get a T1, a T2, T3, and that just means tails and 1, tails and 2, tails and 3. I can get a T4, T5, and T6. Okay, so that's the tails are done. The tails are done. Let me move myself here so you can see me better. Okay, now we do the exact same thing with our other tree. Now we have heads. So I can have heads 1, heads 2, heads 3, heads 4, heads 5, and heads 6. So that's how they would write it out in the list, okay? If it was a table, it would just be tails in one column, the number 1 in the other column. So tails 1, tails 2, tails 3, tails 4, tails 5. It'll keep going, okay? There's a few ways you can write these, but I mainly see them done these two ways. But know that the table is the same thing. It's just written out. It's just written out more, okay? So those are the two ways you can do sample space. So just make sure you have your tree trunks here and then your branches on the second event. Okay? All right. Press pause and we'll do the next one. All right, the next one again has two events. Anytime you see the word and, it's two separate events. The word and is two separate events, okay? You see it here and you see it there, which means I'm going to have to do a tree diagram, okay? So the first event, my tree trunks, those solid tree trunks, is tossing a coin. So here's my tossing of a coin. Remember, your tree trunks are going to be what could happen when you toss that coin. What can you get? Tails or heads or tails, however you want to say it. But there's my tails and there's the heads, okay? There's my tree trunks. I see the word and, which means I'm going to have a, what do you call it? Branches. So what do they have me do next? Spin the spinner. So we're going to spin the spinner. And look what's on the spinner. I have red, yellow, green, and blue. Now, so I don't have to write them all out. I'm just going to abbreviate, okay? So I'm going to do R for red, Y for yellow, G for green, and B for blue. Okay, that way we don't have to write so much. So here's our branches. Tails is going to have 1, 2, 3, 4 branches, which means heads have the exact same amount of branches. So I'm going to start off with the tails. I can get tails and red, tails and yellow, tails and green, and I can get tails and blue. Do the exact same thing to the heads. They're going to have the exact same branches, okay? So I can also get heads and red, heads and yellow, heads and green, and heads and blue, okay? So make sure everything is you're not leaving anything out, all right? And now we can write them in word form if you need to, okay? Again, I'm going to use T for tails and H for heads. So it's going to go like this. I can get tails and red. I can get tails and yellow, tails and green, tails and blue. Same thing, but now it's heads, okay? I can have heads and red, heads and yellow, heads and green, and heads and blue. Okay? So all the outcomes here come out to 1, 2, 3, 4, 5, 6, 7, 8. I can have 8 different combinations. Okay? 8 different combinations by tossing a coin and spinning that particular spinner. That's how Sonic, if you ever go to Sonic and they say we have over 1 million different combinations, that's how they figure out the combinations. Okay, I'm going to show you a quick way of doing it, but they could do a tree diagram, like start with your sodas, so Coke, Dr. Pepper, Sprite, all the other ones, and then the next thing is going to be all the different add-ins you can add in there. Okay, all the syrups you can add in, then all the different candies you can add in, the different fruits you can add in. So that's how they come up with all those combinations. Now, over 1 million combinations obviously is going to take forever if I do a tree diagram, but there's a shortcut, and that is called the counting principle. So go ahead and press pause, and you can go ahead and copy number 1 down, and I'll show you how the counting principle works. So to figure out the total amount of outcomes without even having to do the tree diagram or the table is we're just going to be multiplying each outcome. Okay, now I'll show you how that works. Now, you can use the counting principle even if they ask you which table is correct, because at least you'll have a number of how many outcomes you should have and eliminate the ones that have too little or too many. Okay, so in my first example, we're flipping 3 coins. Okay, 3 coins. Each one of those coins has heads or tails. So this is how you do it. Okay, so the first coin, I'm going to put first coin, has how many outcomes? 2, right? Heads or tails. So that goes here. My second coin also has 2 outcomes, heads or tails. That goes here. And we're doing it 3 coins. So here's my third coin. On my third coin, I have 2 outcomes, heads or tails. That's 2 right here. And we're going to multiply. So 2 times 2 is 4. 4 times 2 is 8 total outcomes. So they just want to know how many combinations can you have. You just find the outcomes of each event and multiply them. Okay. Go ahead and press pause and then press play for number 2. So 8 total outcomes for that one. And once I do this one, okay, go ahead and do number 2. I'll show you how it works with the other ones. All right. Let's go ahead and press pause for number 2 and press play when you're ready. All right, so this one, how many outfits can be made with 4 shirts, 6 shoes, and 4 pants? So if I did this as a tree diagram, I would have the tree trunks would be my 4 shirts, 4 different color shirts, and the branches would be 6 different shoes, and then I would have more branches of 4. But here they just want to know how many outfits can she come up with, okay? So we have 4 shirts, so I'm going to do shirts here. That way you understand where the numbers are coming from. So 4 shirts times 6 shoes times 4 pants. And that'll give her, let's see, 4 times 6 is 24. 24 times 4 is 96 outfits. Whew, that's a lot of outfits. So with 4 shirts, 6 shoes, and 4 pants, she can create 96 different outfits. Okay, 96. So again, you would just go ahead and multiply those numbers. Let me show you how that works on the other ones that we had previously done already. So if we go back to our examples up here, okay, tossing a coin, there's 2 options on a coin. We have a heads or a tail. Okay, so 2 options on a coin. Number cube has 6 options, right? So 2 times 6 gives me 12. 12 outcomes. Take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at the tree branches. You count the branches. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. So that's how the counting principle can actually work if they give you, even if they give you pictures. Figure out how many total outcomes you should have, and then you could eliminate the ones that have too few or too many. Okay, let's look at this one. Tossing a coin. Again, tossing a coin, we have 2 options. And spinning this spinner, we have 1, 2, 3, 4 outcomes. So 4 times 2 gives me 8 total. And take a look. 1, 2, 3, 4, 5, 6, 7, 8. 8. 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. Okay, that's how the counting principle can work. Now I'm going to go ahead and give you the try-outs. Okay. All right, I have some more examples. So these aren't tried outs. Okay, they're more examples. I forgot I had more examples. So go ahead and copy number 3 down. So we're continuing the examples. Okay. 3 and 4, yeah, these are, we definitely have to go over number 3 and 4. So go ahead and copy number 3 down, press play when you're ready, and then we'll do number 4, and then we'll do the try it out. All right, so take a look at number 3. How many 3-digit combinations can be made using 0 through 9? Okay, so this is how this works. We're still multiplying. We're still doing the counting principle, but sometimes we get confused here. So visually, I'll show you how to do this. So we need 3 digits. Okay, so we have a lock that has 3 digits. So I'm going to put a blank for each digit. Okay. Now, these digits can be anything from 0 to 9. So that means I can pick 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So any one of these numbers can be in one of these places, okay? So just like when you flip a coin, what could you get? Heads or tails. I roll a number cube, what can I get? 1 through 6. A combination here, they're telling you can get anything from 0 to 9. So to figure it out, we're going to go ahead and count how many outcomes I can get for 1 digit and then put those for the other 2. So I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possible numbers I can put in this digit. Okay? I have the exact same outcome for my second digit. I can have another of those. So that's 10 again. And then 10 again. Okay. So this happens when it says the numbers cannot be repeated. So here it doesn't matter if your numbers can repeat it. I can have a combination of 0, 0, 0. Okay. So that's fine. So now all you have to do is multiply. So 10 times 10 is 100. 100 times 10 is 1,000 outcomes. So there are a possibility of 1,000 different combinations you can have with a 3-digit code. Okay. Go ahead and press pause and write down number 4, and you're going to see the difference between the wording in 3 and 4. So take a look at number 4. How many three-digit combinations, so we're still dealing with a three-digit code, can be made using 0 through 9. We're still using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So still using 10 digits, 10 different numbers. But now, no repeating numbers. So that means once a number has been chosen, I can't choose it again. Here I could. I can use the same 0, 0, 0. I can have a 1, 1, 1. Here I cannot have any numbers repeated. So this is how it's going to work. I still have 3 digits. There's 1, 2, 3. I'm still using 0 through 9. So I'm still using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I still have 10. I still have 10 numbers to choose from, okay? So the only thing here is I cannot have anything repeated. For my first digit, it doesn't matter. I have all 10 numbers, okay? So I have 10 numbers. But I can't repeat that first number. So one of the numbers that I get to choose from is gone. One of them is gone. Now I only have 9 numbers I can choose from. Okay, that's for my second digit, 9. Now that number cannot be repeated again. Now I'm down to 8 numbers to choose from. Okay, so whenever you see the words like not repeating, you cannot repeat the number, then that means if you look at here, look at the pattern, you're going to be reduced by 1 every single time because one number cannot be repeated. So I have a 9. Another number can't be repeated. Now I'm at an 8. Okay, and if I had more digit combinations, then my number would eventually go all the way down. But here it's just a 3-digit. So I have 1, 2, 3. So it's 10 times 9 times 8. Let's see what that comes out to be. 10 times 9 is 90, and 90 times 8 is 720 outcomes. So 1,000 outcomes, I can have 1,000 different combinations if the numbers could repeat. But once you say that the numbers cannot repeat, you're down to 720 possible combinations there. Okay, so it does make a difference if you can repeat versus if you cannot repeat. The numbers will be decreasing 1 every time. All right, now it's time for your try it outs. Let's go ahead and write that down. And then go ahead and give me, list me the possible outcomes and then tell me the total outcomes. Okay, in other words, give me a tree diagram or a table and then do the counting principle and tell me how many we should have. And then press play when you're ready. Okay, for breakfast, Jamie can choose from cereal, eggs, or a muffin. So there's my first one. Those are your tree trunks. Okay. She can also drink coffee, orange juice, or milk. There's my branches. What are all the possible outcomes? So if you did a tree diagram, this is what it looked like. My tree trunks are her cereal, her eggs, and her muffins. I like blueberry muffins. So her branches are coffee, so C for coffee, orange juice, O for orange juice, or milk, M for milk. I should put OJ. That way we know. Okay. The branches are the same thing for the eggs. So I can have eggs and coffee, eggs and orange juice, eggs and milk. Same thing with a muffin. Muffin and coffee, muffin and orange juice, and muffin and milk. So that's what it should look like. Now, if you wrote it out in a table, then you can do cereal, coffee, cereal, OJ, cereal, milk. Then we go to eggs. Eggs, coffee, eggs, orange juice, eggs, milk. And then the muffin. I can have a muffin with coffee. That is my favorite. I can have a muffin with orange juice, or I can have a muffin with milk. Okay, so that's just the first one. Now the total, you could have added them up together, 1, 2, 3, 4, 5, 6, 7, 8, 9, or multiplied. I have 3, that is your cereal, eggs, muffin, times coffee, OJ, milk. I have 3 of those. You give me 9 combinations. See, and we have 9 here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So on these, basically, you'll never have to really write them out, but you're going to have to choose which one is the correct table, which one is the correct tree diagram. And to always eliminate fast, use the counting principle here to know that I should only have 9. If you have more than 9 or less than 9, those are eliminated. Okay. All right, guys, that's all I have for today. If you have questions, come to the Google Meet, and I will see you tomorrow. Bye.